All right, so our material we're going to do on chapter 10 is two sections, so 10.1, 10.2. So we'll start and finish chapter 10 this week. Okay, there's not really a lot that we do in that chapter. So we're going to look at solving equations, specifically solving systems. So solving systems is something you did, it might be the third time you've seen it, because you do it in Algebra 1, you may review it in Algebra 2, and you're going to look at it again here. But it's when you're solving an equation, and generally you have to find two answers. So each equation that you're going to solve is going to have two letters. At least we're going to start with two. And each letter is going to have an answer. So when you're solving a system of equations, and there's two equations, you're going to give me two answers. When you're solving a system with three equations, there'll be three answers. Yep.
That sounds very hard.
So 2 and 3 that's the most we do. In general, system of equations can go as high as you want, but 3 is the highest we do. Question, yeah.
I don't we never did Algebra 1. I don't know. Anyone that was from Overlook and stuff?
Yeah. I didn't do it.
I don't know if
Yeah,
that'll
it's 'cause it
I don't know if that'll
applied
affect us today. That's
Algebra
all.
2.
No, you should be okay. Yeah.
It'll just be harder.
So we're going to look at a couple different methods we can use for solving systems. One is substitution. Okay, you've heard of substitution. Another one is elimination. So substitution and elimination. Those are really the two that we look at. This first one, you don't have to solve it. Okay, we're going to solve it after. I just want to set it up.
Sorry, I don't mean to interrupt the class.
Yep.
I just want to let you know I'm getting dismissed for my.
Okay, yeah, just sign out when I
I don't want to go. Thank you. I just wanted to ask if you make any alterations to the homework and put me on me, it's going to be an
Yep, it'll be in the video tonight. Yeah.
Alterations you do in class. Okay then. I'll see you at home sweet.
So this problem is asking us about the length and the width of the rectangle. And they give us two facts, the perimeter and the area. We're going to need the formulas for each of those. Let's start with area. Does anybody remember what the formula is for area of a rectangle?
Length times width.
Yep.
I'm so good. Thank you for that.
Perfect. And the second one is perimeter. What's the formula for perimeter of a rectangle?
All the sides.
That's not a formula.
And what would that be if you did it for a rectangle?
2L plus 2W.
Yeah, you'd have two L's that are the same, and you'd have two of the W's that are the same. Yep. Okay. So all they want us to do with this first part is set it up, and then after, we'll solve it. Okay. What's going to get plugged in? Let's start with that bottom one. Right. We're going to fill in 100 for P. I started with that one because that's the first piece of information they gave me. So 100 equals 2L plus 2W. So that equation by itself you couldn't solve.
No.
Okay. The problem with it is there's two variables. If you have an equation with two variables, you need another equation to solve it. You always need as many equations as you have variables for the kinds of problems we're going to do. What are we going to fill in? Right here.
300 equals L times W.
Yep. And now with those two equations together, we'll solve it in the next step. But for that example, that's all they want you to set up. Any questions on just the setup? Now, L and W, I'd say those are good letters to use here because it represents length and width. X and Y is going to come up more often as the two letters. But you can use any two letters you want. All right, so the first method that we're going to look at that this problem would be good for is substitution. Elimination would not work on this. So we'll talk more about elimination in a little bit. Okay, how many people remember substitution?
I've heard the word. word.
Heard the word.
I forget what it means, but yeah.
All right.
I've heard both of the words before.
Mm-hmm.
But you forgot.
What was
Well,
the
are you
substitution?
smart?
Elimination.
Elimination.
I know.
So to use substitution, I think I broke it into 3 steps. Okay, the first step with substitution is you're going to pick one of your equations to work with, and you're going to get a variable by itself.
Oh wait, I do remember.
So in this first step, for our problem, you would have 4 choices. You could get L alone in the top, or you could get W alone in the top one. Or you could get L alone in the bottom, or you could get W alone. But you have to do one of those 4 things. Pick a variable and get it by itself. Generally, we try to pick the equation that would be the least amount of steps. Once you get a variable by itself, we're going to plug that into the other equation. Okay, so let's leave a little bit of room to write step 3, but let's start looking at this problem. I'm going to rename it with x's and y's, okay, because that's how you're normally going to see them. So that's the same problem. I just changed L and W to x and y. Okay. So which equation do you think would be easier to get a variable by itself?
X and Y equals 3.
Top one or the bottom one?
Bottom.
Yeah. You can get either the x or the y by itself in the bottom in 1 step. You can do it in the top, but it would be more than 1 step. Which letter do we want to try to get by itself?
X.
Okay, we'll do x. How would you get x by itself in the bottom?
You would subtract y from, or divide y from 300.
Yeah, you divide each side by y. So when you do that, x would be by itself. And what would you have on the right?
3 over y.
What is it again?
X equals 3 over y. Or 300 over
300.
y, my bad.
Yeah. Okay, so that's step 1. Pick an equation and then get a variable by itself.
So then we plug that into the X spot. And
Yeah. So now take what you just got from step 1, you're going to plug that into the other equation, and you're going to plug that in right there. So take what you got in step 1, plug it into the equation you haven't used yet. So we're going to have 2y plus 2, and this time we're not going to put x. What are we filling in for x?
300 divided by Y.
So 300 divided by y, and since that's a fraction, if you want to put it next to another fraction, you can. So when we multiply straight across it, makes more sense. All right. And now the next part of step 2 is to simplify. So we've got 2y plus, and then we multiply straight across.
600 over 1y.
600 over 1y equals 100. All right. So now, looking at that equation, we only have one different letter. We have the same letter twice, but it's just a y. We got rid of the x now. So now we don't want to have this divided by y. That's going to be kind of a mess to deal with. So we want to do something here,
Multiply
here,
by Y.
and here. Yeah. We want to multiply everything by y. What that's going to do is make it so there's no more fractions. So times y, times y, times y. Okay. In the middle, what happens with the y's?
They cancel.
They cancel. So that's good. Okay. What's 2y times y?
2y squared.
2y squared. We already said in the middle, the y's are gone. 600,
Equals 100y.
100y.
And we square root that equation.
Now, what kind of equation is that?
The one that goes from like
Cubed.
2, 1, no.
It begins with a q.
Quadratic.
It's a quadratic. Yep.
Good job.
Great.
I want to roll.
Okay. So because that's a quadratic, we have 2 ways we can try to solve it. We could factor it, which this isn't going to factor nicely, or we could use quadratic formula. That's what we'll have to do. Regardless of which method you use, you're supposed to get it equal to something first. It's not supposed to be equal to 100y.
0.
It's supposed to be equal to 0. So the easiest way to get it equal to 0 is just put this on the other side. You can't combine it with anything because there's no other y's to the first power on the left side. Now we have nothing on the right. On the left, you've got 2y squared minus 100y
Plus 600.
plus 600. Now it's ready to use factoring or quadratic formula, but factoring won't work. This is one other thing we could do. What are all of those numbers divisible by?
2.
2. So if you divide everything by 2, it just makes all the numbers smaller, and you still get the same answer. Is it necessary? No. But I'm going to do it. And everything gets a little bit smaller. Okay, so when we use quadratic formula, remember there are 3 letters. What are the 3 letters we use in the formula?
ABC.
ABC. Let's make sure we know which one's which. Okay, this is the formula we're going to fill into. And not every problem that we do is quadratic. Okay, I think this is the only problem today that comes out quadratic.
Don't put an X on the test.
No guarantee.
Please.
There might be one.
Please.
What's A in this problem?
How do you figure out what
Negative
what?
50.
So for A, you look at the number in
Wouldn't it
front of
be
the
one?
y squared.
It would be 1.
0.
A is 1. How about B?
Negative 50.
So that's the number in front of the y.
And then 300.
And 300 is C. Okay. So now fill in those numbers and see what you get. Okay. What's negative? Negative 50. Positive 50. B squared. What's negative 50 squared? Same as negative 5 squared with 2 zeros. 2,500 minus 4. What's A?
1.
So that doesn't do anything. We don't even need it.
300.
C is 300. And that's divided by
2 times 1.
2 times 1, which is 2. Okay. So there's probably one more step we can do, and then we need to calculate it. So 50 plus or minus 4 times 1 is how much?
4,
4.
What's 4 times 300?
1,200.
So I'm going to end up with 2,500. Take away 1,200.
Which is 1,300.
It's 1,300. Okay, and that's what y is. Now we'll type that in. See what we get. When I type that in, how many answers do I get?
2.
2. Yeah, one's a plus, one's a minus. So let's make a chart. So we're going to have a y1 and a y2. And remember, we're solving a system. So we're also going to have an x1 and an x2. Let's start with what's on the left.
Wait, what's the x1 and the x2 for?
We don't know yet.
Well, when we're solving, remember there was an x and a y in the original problem. So we have to find both.
I forgot that.
Because we did substitution, we got rid of the x. So we're going to come back and get x at the end. But that's extremely easy once we know y. Question? Question?
No, not really.
Okay. So once we know y, just take 300 divided by y, and then you have x. Okay? But the hard part in this problem was getting y. But we're about to figure out what it is. Okay, so type that in. So you got 50 plus the square root of 1,300. Okay, I'm just going to do that first. And then what am I dividing by? 2. So one answer is 43.0, let's say 028. And what's going to be different when I type it in to get my second answer?
The negative.
Yeah, I'll just make that a negative. So 50 minus the square root of 1300 and divided by 2, 6.972. So those are our two y values. What are the other two values that we still need to find? X. But we have a formula right here that tells you how to find x. X is 300 divided by y. So just take 300 divided by the answer we just got. Let's do the first one. So 300 divided by the answer we just got, 43.028. 6.972. And what am I going to type in for x2?
300 divided by 6.972.
Yep, 6.972. And I get 43.0029. What do you notice about the two answers? Yeah. Remember what we were doing? We were finding a rectangle. The reason there's two different rectangles that have an area of, what was it? Area of 300 and a perimeter of 100 is because you could have one rectangle go back here. You could have one rectangle like that, and you could have another rectangle like that. So are they really the same rectangle? Yeah. It's just one is standing up on the short side, one is laying down on the long side. That's why we get two answers, and the numbers just switch places.
Wait, give me the next.
So this is the length, this is the width.
If they're really close like that, but they're similar enough, is that okay? Like,
Yeah, they should have been exactly the same. It's probably just because I rounded.
okay.
0.028, 0.029. Yeah, they should have been exact. Okay, but again, we didn't call them L and W in this problem, but like that's your lengths and these are your widths. We call them Y's and X's instead. Oh, I didn't write down the last step. We already did the last step, but the last step is what we did right here. We took our answers that we got, 43 and 6.9, and we plugged those back into the original problem. So by the time you get to step 3, you've done like 90% of the work. I would say like 5% of the work is in step 1. That one's pretty quick. Probably like 80% of the work is in step 2. And then the rest is step 3. Step 2 is usually the longest step. Okay. So any questions on those answers? So biggest thing to remember when you are solving a system, you need to make sure you give me an answer for each letter. This one had 2 answers for each letter, but all of them going forward from here will have 1 answer.
I thought you said it needs more than one answer.
Yeah.
What's that?
Y1 and X1.
Yeah.
Yep, so this is 1 answer. It has an X and a Y value, and this is the second answer.
So that's not 4 answers?
No, because they together, the X and the Y make 1 answer.
Okay.
If you wanted to think of it as 1 answer, it's like a coordinate.
Oh, yeah.
6.972, 43.208. That is 1 answer. Okay. Any other question on that? Does anybody need to write down the quadratic formula again?
Come in my
You have that?
Yeah. You're not like that.
You got it? Okay. All right, let's try another one with substitution. This one's a lot easier. This one's not quadratic. How do we know it's not quadratic? There's no exponents of 2's. Okay, so first step, pick one of those equations, and we're going to choose to get a letter by itself.
First one.
I definitely think the first equation, if we just label them, the first equation is definitely the easiest one. And which letter is pretty easy there to work with? Yes. When you're doing substitution, if you can look for something that has a 1 in front of it, that's going to be the easiest thing. So we're going to get y by itself in the top one.
Would you just subtract 2x?
You just subtract 2x. So what would be in that box?
Negative 2x plus 5.
Yeah, you can write negative 2x plus 5 or 5 minus 2x. Same thing.
And then you would plug that into the bottom equation where y was.
Yep. So now fill that in to the bottom equation. So like I said, the first step that you did, that's like 5% of the work, getting the variable by itself. This is the biggest step, okay, doing this out. When you plug in for y, what symbol are we going to want to write down that's not there right now? Something
Parentheses.
Right. You got to put parentheses because it's 2 times everything you change y to. So both of those get doubled. If you don't put a parenthesis in there, you might forget to do distributive property. Okay. Any question on how we got y by itself in the first one? Or why we filled it in for y in the second one? Okay. Kind of already told you, but what's the first step you're going to have to do with that 2?
Distribute.
Yeah, it said you got to do distributive property. So you get 3x. What's 2 times negative 2x?
Negative 4
4x.
plus 25.
And 2 times 5?
10?
10.
Oh. I knew that.
Oh yeah.
Yeah, not 5 squared. That would be 25.
Please.
But 2 times 5 is 10. And do we distribute the 2 to the other 2?
No.
No, that's on the other side of the equation.
We need to.
So now, is that a quadratic?
No.
No. So you don't need quadratic formula at all for that one. What could you do next in that
Combine
equation?
like terms.
Combine like terms. What's 3x minus 4x?
Negative 1.
Negative 1x. Okay. Next up.
Subtract 2.
10.
Well, because it's linear, you don't want to get it equal to 0. You can get the variable alone.
Subtract the 10.
10.
So I would subtract the 10.
Negative 8. And then once you divide it by negative 1 to get it.
Right. We don't want negative x, we want positive x. So yes, if you divide by negative 1, you get x equals how much?
8.
8. Okay, so we got x. What else do you still need?
You have
Plug
to
it
plug
back
in for
into
y.
the original formula.
Plug it back.
Okay.
From,
So take that,
and plug it into Hager.
and I would say fill that back in,
For the first one.
right there. So you already have y by itself. So take 8 and fill it in for x. Again, I would put it in parentheses so
Negative 11.
we know it's multiplication. So it's, going to be negative 16 plus 5, which means y is negative 11. Now there's 2 ways you can write your answer. You can write it x equals y equals, or you could write it as a coordinate.
Wait, but that's only one answer.
Right, this one only has one answer.
I thought
'cause-
it needed more than 2 to be this type of equation.
So you got an answer for x,
Yeah.
that's part of the answer, and then you also got the y, that's
But
the
I
other
thought you
part.
said you needed
That's
2
two
answers
answers.
for it to be a whatever
Yeah.
equation.
That's
You
two.
need one x and one y.
Oh.
Yeah, so you need to have an x and a y. Does that make sense?
I think so.
Okay. So in this particular problem, because it's not quadratic, there's not another pair of answers. Now, that coordinate, if you write it that way, that's something special. What would happen if you were to draw each of those on the calculator.
Will
And
they
then
intersect at that point?
that's where they would cross. Yep. So you get a line here, you get a line here, and that's where they would
Wait,
cross.
so could you just plug in those two into the thing and then see where they intersect, and then that would be your answer?
Well, you'd have to solve it for y, and you'd get
Oh,
all
yeah.
kinds of fractions. Yeah. Okay, so keep that in mind, right? We just drew two lines, that's where they crossed. So we had something like that. What else could happen when you draw two lines?
They could be on top of each other?
Right, you could have two lines that are exactly on top of each other, and where do those cross?
Never.
Every point.
Every point, yeah. The opposite of never, they cross everywhere, because they're right on top of each other. What else could happen besides,
Parallel?
yeah, they could be parallel. And where do parallel lines cross?
Never.
Never. So that gives us basically those three things that can happen when you solve linear equations. Linear, not quadratic, not like the rectangle problem. That was different. Okay, one solution, they'll cross in like an X shape. No solution, could be parallel. Infinite solution, they're exactly the same line. The last problem we did was that type, one solution. Okay, we are going to look at no solution and infinite. But first, I want to show you elimination. Okay, so is there any question on substitution? The last problem that we just did would have been good to do with substitution or elimination. You could easily do elimination in that problem. In this problem, no. This one's not set up for elimination. So elimination works. Okay, don't write it down yet because I want to show you what elimination is first. But elimination works when you have a column with one letter, a column with another letter, and then a column without any letters. That's a pretty standard pattern for elimination. This problem doesn't have that. It doesn't have a column with just y's and then a column with just x's. It has like an x and a y multiplied together. That's why elimination wouldn't work, and you have to do substitution. This one that we just did, elimination would have been perfect. Column for x's, separate column for y's, separate column for just the numbers. I'm not going to go back and do this one with elimination. Substitution worked fine. But I'm going to do the next one with elimination.
Is there any problems where you have to use elimination if you can't use substitution?
Where you have to use elimination?
Yeah.
No. No. So the idea with elimination is you are trying to get something to cancel right away. And by getting something to cancel, you only have to work with one letter instead of two.
What does this definition mean? Because I don't understand it.
We're gonna go over it. So, for example, suppose I had these two equations. Let's do a different number. And I wanted to solve that. If I want to solve that with elimination, then I want to try to make one of those letters disappear. Look at the first two. If I add those together the way they are, do they add up to 0?
No.
That doesn't work. Look at the second two. If I add those two together the way they are, do those add up to 0?
No.
No. So then what that means is I need to do that. I need to multiply one of these equations by something to make a letter cancel. Let's say I wanted the x's to cancel. I want to add these up and get 0. What would the bottom one have to be?
2.
2.
-2.
It would have to be a -2. What can you multiply that by?
-2.
Yeah. So if you multiply this entire thing by -2, that's called a linear combination. What would the bottom one turn into if you did that?
-2.
-2 x
Negative 8y
-8y
equals -12.
and equals -12. So for the purpose of this problem now, this middle one is gone. You changed it. You multiplied it by -2. Now, if you add this first column together, what happens?
They cancel.
Yeah, they cancel out. That's called elimination. And then we go from there. So the whole goal with elimination is to try to make one number and another number opposites. 2, -2. 3, -2. You're only dealing, you can't usually eliminate both, but you can eliminate one variable. Yep.
And then you can just solve the equation from there.
Right, and then that variable's gone. So the goal again is you must get the coefficients of one variable to be opposite. 2, -2. So you want to get the coefficients of one of the variables to be the opposite. If they give you a problem and they're already the opposite, great, add them up the way they are. I checked out with you guys on this one and they weren't. So sometimes you have to multiply. What did we multiply by in the last one?
-2.
Yeah. So when I say sometimes you have to multiply first, that's what I mean. Multiply by -2. How many equations did we multiply?
1.
Just one. Just the bottom one. Sometimes you have to multiply the top one as well. Depends. Depends on the numbers. Okay, but you can multiply by any number you want except there is one number you cannot multiply by.
0.
Right, because if you multiply by 0, then you've effectively erased everything. It's all 0. But other than 0, you can multiply by anything you want. I try to avoid multiplying by a fraction, because usually that's going to come out messy.
What if it's like 4 and 2 and you multiply by 1/2? Would that mess it up?
Well, that would come out okay, because it's even.
Yeah.
Yeah, that'd be okay. All right, so let's look at this one. Okay, so we're going to solve with elimination. Let's check the x's first. If you add the x's up the way they are, do they cancel out?
No.
No. Okay, let's check the y's. If you add up the y's, do they cancel out?
No.
No. So then we're going to have to do something to make either the x numbers opposites or the y numbers. So the first thing we do is pick a letter.
X.
X. Okay. So we want to make these numbers opposites. Now, let's look at the two numbers we have. Can you multiply 2 by something not as a fraction to make it 3?
No.
No.
So then that means we're going to have to multiply both equations.
Can we get it to 6?
Yes, we want to try to get 6's. What could you multiply the top one by?
3.
3. And we're going to basically do that.
And then the bottom one by 2.
And if we multiply the bottom one by 2, let's see what that gives us. So if you multiply the top by 3, what's 3 times 2x?
6x plus 9y equals 15.
Okay. That's the same equation that we started with. Just think of it as like a larger version of it. But it's just tripled. But it's still the same thing. How about the bottom one?
Negative 6x plus
10y
equals 52.
First was equals 2.
Okay. now you're going to add your columns up. What's 6x and negative 6x?
Zero.
That's the whole point of elimination. You get rid of one letter right away. What's 9y plus 10y?
19.
19y. And what's 15 plus 42?
57.
57. So it's a little bit more work up front, but the equation you have to solve now is very simple.
And then you divide by 19.
And that does come out nice. What's 57 divided by 19?
3.
3. Yep. Okay, so that's half your answer.
And then you plug it back in.
Yep, and we can plug it back into the top or the bottom.
To the top.
Top.
To the top. So where do we plug that back
Where
in?
y is everywhere as well.
Yep, and then it'll only be in one spot.
Now, would we be plugging it into the one that's multiplied by 3 or not?
I would go back to the original because the numbers are smaller.
So it doesn't matter?
No, you could plug it into the other one and it would work. It would work fine there too. Yep.
So it'd be 2x plus 9 equals 5.
So 3 times 3 is 9 equals 5. Yep.
Which is x equals negative 2.
So minus your 9. What's 5 minus 9?
4, negative 4.
Negative 4.
And then divide by 2.
X equals negative 3.
And that is the other part of your answer. So together, the x and the y make up one answer. Well, I put it this way. They make up one coordinate. Okay. Any question on that one? Okay, so that's another problem where if you did it on the calculator and drew it, the lines would make like an X shape. All right, so I already showed you guys the 3 different things that can happen.
Wait, so if we did that on the calculator, we would get those coordinates where they meet?
That's the intersection point, negative 2 comma 3. Yep.
But are you able to put that in I can put that in the calculator now and then graph it? I can press intersect.
No, you need to solve it first. Okay.
No, you'd have to get all this, you'd have to add the 3x to the other side, put it in y equals mx plus b, and divide by 5. So you'd have all kinds of fractions.
Gotcha.
You get the same answer, but yeah.
A lot more work.
Okay, and I showed you guys that. So now let's look at this one.
Wait, could you go back to that?
It's just the one solution, two solution, no solution. Or one solution, many solutions, no solution. Many, infinite. So now let's look at that one. This time it's going to be a little bit easier to eliminate one of the letters because you can multiply the smaller number directly to get the bigger number. Which letter do we want to try to get rid of, X or Y?
Either, because it will just cancel out.
So if we want to get rid of that X, that's a negative 6. We need that number to turn into a what?
Positive.
Needs to turn into a positive
Times
6
3.
3.
times 3.
So 6x minus 9y equals 15.
So bottom I kept the same, and then you said 6x minus 9y equals 15.
Which
Add
means
them up.
they both cancel out.
So these cancel. Negative 9y plus 9y, that cancels. So you got to keep something over there though.
0.
Yeah, there's nothing, 0. And 15 plus 10?
25.
25.
We always
Okay.
add those two?
You always add your columns up. Yep.
So this would be a no solution then?
This is a no solution. When you get to a step where all your letters are gone, one of two things happens. If all the letters are gone, it's either no solution or an infinite amount of solutions. This one's no solution because that is false. 0,
It can never eat.
But
Does
if it
not
was
equal
25 equals 25, it'd be infinite.
yeah.
Got it.
And that's, we'll look at that one, yeah. That'll be our last 2 variable, and then we're going to finish with a 3 variable. Okay. So now, pick a letter. Do we want to try to eliminate X or Y?
X.
Okay.
I'm ready for this.
And this one's going to be
It's a 1. What do we need to turn it into?
2.
Needs to turn into a 2. So let's multiply everything by 2. What's what does the first equation turn into?
2x minus 6y equals -4.
4. And the bottom one just stays the same.
So it would be 0 equals 0.
So when you add this up, those cancel. Those cancel. And yeah, what's -4 plus 4?
0.
0. So this time we ended up with a true statement, but you don't write true. The answer is all real numbers. All real numbers. What makes that one different from the last one?
It's a true statement.
Right. That's false. That's true. Yeah. So that's an example of elimination with each type. No solution, infinite solutions, and I did a single solution somewhere, right here. And then substitution, we did a single solution, 8, -11, and then we did another single solution. No, that was a 2 solution because it was quadratic.
Wait, can you go back to the one with no answers for a second?
That's the no answer. And that's the infinite amount of answers. Okay. Any other questions on that one?
No.
Okay. Now, three equations is exactly the same idea as 2. The only difference is it's more steps.
Is it 3 in both of them or just 3 in one?
It's going to be 3 in both.
Okay.
It's going to look just like this. 3 and 3.
Oh, Jesus.
We are not going to solve with substitution. Substitution with 3 it gets kind of messy. We're only going to do elimination. Okay, so how do you do elimination with 3 variables? Well, same way you do it with 2. You need to pick, I'll write the steps and then we'll do the problem after. You're going to pick a variable and you're going to eliminate it in 2 of the equations. So the one thing about this method is you have a lot of choices. I'm going to try to give you some hints at how to make the best choice to make life as easy as we can. Okay, so pick one variable and eliminate it in 2 of the equations. Okay, next. Once you've made that choice, you're locked in now. Once you pick a variable to eliminate, you have to use that variable again. So pick.
Why does it only need to be eliminated at 2 of them? Why not all 3?
You won't be able to do that. You'll see why. You can only eliminate it in 2 at a time. So you're going to pick a variable and eliminate it in 2 of them. Well, you could do all 3, but I'm going to hold off on that till tomorrow. So actually, yeah, you can do that. Well, just watch this. So you pick a variable, eliminate it in 2 of the equations. Now pick the same variable and eliminate it in 2 different equations. It has to be different than the 2 you picked in step 1. Because if you do the same equations again, you're just repeating the first step all over. So pick the same variable and eliminate it in 2 different equations. Different equations than step 1. Once you do those 2 steps, you're going to have turned your problem into having 3 variables into 2. Once it's 2, then you can solve it like I just showed you before. Okay, so now you will have a system of 2 equations. Follow the steps we learned earlier. I'm going to leave that up and give people a minute to copy down example 6. There's only example 6, example 7, and that's it. So first of all, I will always give you as many equations as you have letters. There's 3 letters, you'll have 3 equations. 2 letters, 2 equations. And that's all you'll ever have. Okay, we don't look at 4 letters. Once you get to 4 letters, then we want to switch to a different method because this is going to be too much to try to do 4 letters with. Okay, so the first step says to pick one variable and eliminate it in 2 of the equations. Just so we can clearly talk about which one is which.
X.
I'm going to call those equations 1, 2, and 3.
Either one of them has 1, so can you get it to match any of them?
Probably number 3.
Yeah, so I think X is a good letter to eliminate.
Or you could do the 2.
You know what, I'm going to reword, I don't like how I worded that. Pick the same variable and eliminate it in a different equation. I didn't reword it a lot, but I pick the same variable and eliminate it in a different equation. Okay, so what letter did we say we're going to try to get rid of?
X.
X.
The
Yeah.
1.
I feel like Y was.
X is a good one because
There's a 1.
you have an X with a 1 in front of it.
So it means it can match any of them, right?
Yeah. So we're going to try to eliminate the X. We need to pick 2 equations to do that in. So we agreed we're going to use 3.
Yeah.
Do we want to do 1 and 3 or 2 and 3?
1 and 3.
1 and 3. Okay, so now I'm going to write down what we're going to do. Using equations 1. Okay, when I write a number and I circle it, that refers to an equation. So using equations 1 and 3, let's eliminate X. Now I said, do you want to do 1 and 3 or do you want to do 2 and 3? You're going to have to do both. So just which one do you want to do first? So let's copy them down.
If we did 2 and 3 first, would that matter?
No. Nope. So that's equation 1. If you copy something wrong, that messes up your whole thing. So copy it carefully. Okay, forgetting about equation 2 for now. Okay. How would you eliminate, if you want to get the x's to cancel?
100 times the bottom by -2.
We need to multiply the bottom by -2. So what happens to the top?
Stay the same.
Okay, so I just copy it over. 2x plus 3y times z equals -1. And I copy it over because I want to have space to do my work. What's -2 times x?
Negative 2x.
Perfect. What's -2 times 4y?
Negative
8y.
-8y. What's -2 times 3z?
plus 60.
Plus 6c. And what's -2 times -8?
16.
16. So if you did this right, you're going to get an equation now that doesn't have an x in it. What's 2x and -2x?
0.
That's gone. What about 3y? Take away 8y.
Negative 5y.
Yep. -5y. -1z plus 6z.
5.
Yep, 5z. Actually, I think something nice is going to happen in a second. What's -1 plus 16?
15.
15. Now, normally that's it. You just use that equation. But what do you notice about each of those numbers?
Still have 2 variables.
Yeah, they all are divisible by 5. So if we want to divide everything by 5, it'll make that equation even simpler.
3y plus z equals 3.
Negative 1.
Negative 1.
Negative y plus z equals 3. Yep. And I'm going to call that equation 4. So now we have an equation that just has a y and a z in it. We need one more equation with a y and a z.
So
Which will be
3 and
equation
2.
number 2.
So now, we can't work with 1 and 3. We're going to get the same thing again.
2 and 3.
We can do 2 and 3. Yep. So now, using 2 and 3, you don't have a choice. You need to eliminate x again. You can't pick a different letter. Okay, so using 2 and 3, eliminate x. Let's copy them down. 3x minus 2y. What was the number on the other side
Negative 15.
for equation 2?
Positive 15.
Positive 15. And for equation 3, negative 1x plus 4y. Minus 3z equals negative 8. Okay, so now I'm going to eliminate x.
So now you multiply by negative 3.
Yep, multiply the bottom by negative 3. Okay, again, it's a little bit more writing, but I like to just copy over the top one. 3x minus 2y plus 2z equals 15. And now do the bottom. What's negative 3 times x?
Negative 3x.
Negative 3x.
Minus
Negative
12y.
minus 12y
Minus 9z. No, plus 9z.
plus 9z.
4.
24.
24. Okay, add those up. What's 3x and negative 3x?
0.
What's negative 2y and negative 12y?
Negative 14.
2z and 9z.
11.
11z and 15 plus 24.
39.
39. And that is another equation that just has a y and a z. Now, the part that has 3 variables is done. Now, this is like a problem we've done before.
So now you take the 4 and the 5 and you do it.
Mhm. So now, I'm just going to write down, I don't know what we're going to do yet. Using equations 4 and 5, we're going to do something. We're going to eliminate a new letter. Let me copy them down first, and then we can decide. Negative y plus z equals 3. And 14y plus 11z equals 39. So, using those two equations, what letter do you want to eliminate?
Z.
Why not y? Because one of them's already negative. We would have to.
Yeah, we could do, it's probably the same amount of work. You want to do y or z?
Y.
Y? Okay. So let's eliminate y. Does the bottom equation get multiplied by anything?
No.
No. So we're going to copy it over. But what does the top one get
But
multiplied
isn't
by?
it negative 14y?
Yeah, so still need to be.
Because we did negative 2 plus negative 12, so it'd be negative 14y, not 14y.
No, it'd be.
It would be
14.
negative.
Did I copy it? I could have copied
Yeah,
it.
you
Oh,
copied
You
yeah.
copy, there's a negative in front of it.
Yeah, there was a negative. We just didn't copy it.
I don't know.
Yeah, we can still eliminate y. That's okay. So what do you have to multiply the top equation by?
Negative 14.
Negative 14. Okay. What's negative 14 times negative y?
14.
14y. What's negative 14 times z?
Negative 14.
Negative 20.
Negative 14z.
So that's
And what's negative 14 times 3?
Negative 42.
Yep. And again, I'll give you a hint. Most of the questions I give you, you're going to get nice answers. You're not going to get decimals. So let's see what happens. What's 14y? Take away 14y.
0.
So now we've eliminated the y's, and we're going to be left with an equation that only has a z. Okay. What's 14? Negative 14 plus 11.
negative 3z.
Negative 3z. And think of that as 39, take away 42.
Negative 3.
Negative 3.
So it's going to be equal 0.
So now, how do you get rid of that negative 3?
Divide by negative 3.
So that's gone.
So it's all solutions. All
I don't know.
What's
No.
negative 3 divided by negative 3?
0. 1.
1. So there's our first answer. Z is 1.
And then we plug that back
Right.
in.
So once you get your first answer, you're like 85% done. Okay, you've done most of the problem. Now go back up to equation 4 or 5.
4.
4.
4, negative y plus z equals 3. Okay, so let's do negative y plus z equals 3. And now we know z is what?
1.
1. So negative y plus 1 equals 3. How would you move the 1 over?
Negative 1.
Subtract 1.
So we get negative, we get 2. And that would mean y equals,
2.
Negative.
Negative 2.
well, negative y is 2. So what's positive? y?
Negative 2.
Negative 2. So now that we have z and we have y, we can go back up to any of them, any of the original, to find x. Which one do you think would be the easiest to find x?
3.
Yeah, because that already has a 1 in front of it. That's the easiest one. Okay, I'm just going to find x right here. So we got x plus, what did we get for y?
2.
2. And then we've got minus 3z. What did we get for z?
1.
1 equals negative 8. Okay, 4 times 2 gives me
8.
8.
Minus
What's
3.
minus 3? What is 8 minus 3?
5.
So x plus 5 equals negative 8.
Subtract the 5.
Subtract 5. And what do you get?
Negative
13.
Negative 13. Yeah. So solving a 3 variable, it's definitely a lot more steps, but it's not really harder, it's just longer. Okay, it's the same steps you keep doing over and over. So just to kind of just take a look at it. Those were our steps. So we got rid of the 2 letters to get equations 4 and 5, and then from there we were able to solve it just like a 2 variable system. Okay. Any question on that one? Let's try one more of those. Now we'll be done. Now this one it has a spot missing. So what do you think you could fill in?
Y. 0.
0.
You could put in a 0y if you want to. Whenever there's a 0, that's nice because well, it makes the arithmetic a little easier. Okay, so once we write that down, then the first thing that we want to decide on is what letter we're going to eliminate. And then we go from there.
X.
Okay, so we're going to eliminate x. Why x?
Because there's already a 1.
Yeah, there's already a 1 in front of it, so I think that makes it a good choice. What other letter also has a 1 in front of it?
Y.
Z.
The top z has a 1 in front of it. So you could have eliminated z just as easily. Okay. So we decided we're going to eliminate x. Let's pick 2 equations. Which 2 equations are we going to use first?
1 and 2.
Okay. So I'm going to write down what we're going to do. Use 1 and 2 to eliminate x. Okay, let's copy it. And equation 2. Okay, when you copy it, it's always a good idea to double check it because unfortunately, if you copy one thing wrong, then everything's messed up. So x minus y plus z. Okay. How are we going to eliminate the x's?
Multiply by 2.
Negative 2 on the top.
Negative 2 on the top.
It'd
So
be
I'm going to do
negative
this
2.
one sideways, so it takes up less space. What do you get when you multiply that by negative 2?
Negative 2x
Plus
plus
2y.
negative z. 2z.
2z.
Equals negative 12.
Okay, and what about the bottom one?
It stays the same.
Just copy it over. So 2x plus 0y minus z equals 6. Okay, now let's add them up. What's negative 2x plus 2x?
0.
Gone. 2y plus 0y?
2y.
2y. Negative 2z and negative 1z.
Negative 3z.
3z. And negative 12 plus 6.
Negative 6.
Negative 6. I'm going to call that one equation 4. So now you have one equation with a y and a z.
Now would you do the 1 and 3?
Yep, we got to do it again. So now we're going to get another equation with just a y and a z. And you said you want to do 1 and 3? Okay, let's copy it down. And what was 3? 2x plus 2y minus 3. Equals 12. Okay, double check I got everything right. Okay. All right, eliminate x. So what do we have to multiply by to do that? Negative 2 in the top. Same thing we did last time? Yep. All right, so what's the top one become?
Negative 2y.
Negative 2x plus 2y. Negative 2z. Equals negative 12.
Yep. Again, we did that one earlier. And what happens to the bottom one?
Stays the same.
Stays the same. So 2x plus 2y, 12. Okay, add them up. What's negative 2x and 2x?
Yeah.
Gone. 2y and 2y,
4y.
4y. Negative 2, oh, we're not, we're going to get the same thing we got last time, but no, we're not. What's negative 2z and negative 1z?
Negative 3z.
Negative 3z. And what's negative 12 plus 12?
0.
0. Okay. Let's call that equation 5. All right, so now we have equations 4 and 5, and they each only have y and z. Okay. So now we got to do something with 4 and 5. We don't have to decide yet. We can just start writing it down. So use equations 4 and 5 to eliminate, and now let's write them down and then decide what we want to do. 2y minus 3z equals negative 6. 4y minus 3z equals 0. Okay. Which letter do you want to try to eliminate?
Y.
Z.
I mean Z. Yeah.
I would do z because they're almost ready to eliminate the way they are.
Yeah, just do it by 1.
Just multiply it by,
Negative.
Plus.
yeah. Which one
Doesn't matter.
wouldn't matter? So what would the top one become?
Negative 2y
Yep,
plus 3z
that's 3z
equals 6.
equals 6. And the bottom one?
Stays the same.
Yeah, there's always one that stays the same. 4y minus 3z equals 0. Add them up.
Be 2y equals 6.
2y equals 6.
Divided by 2.
Divided by 2.
Y equals 3.
Okay, y equals 3. All right, so again, once you get that first letter, you're like 85% of the way there. Now pick either equations 4 or 5 to plug back into. Which one do you want to do?
The 4.
4. 2y minus 3z equals negative 6. And what can we plug back in, because now we know it?
Y.
Y.
For 3.
Y is 3. What's 2 times 3?
6.
6. Alright. How would we bring that 6 over?
Subtract it.
Subtract it. What's negative 6 minus 6?
Negative 12.
Negative 12.
Very good, yep, negative 12.
Divide
And
by negative 3.
divide by negative 3. That's gone. What's negative 12 divided by negative 3?
4.
4. Perfect. So we got z.
And then we just pick any.
And now we can pick any of them.
We
Oh.
should do number 1.
Number 1, x minus y plus z. X minus y plus z, I think it was equals 6.
Yep.
Yep. Okay, x we don't know. Y we know is 3. What do we get for z?
4.
4. Okay, what's negative 3 plus 4?
1.
1. And bring the 1 to the other side. And get x equals
5.
5. Perfect. So that's, yeah, actually that way worked a little better. It took up less space. So really we had, I would say, 1, 2, 3, 4, about 5 steps. I don't think you could do it much shorter than that. And the last 2 steps, those were really easy because we were just plugging back in. It's really steps 1, 2, and 3 that most of the work is in. Okay. Any questions on that?
The final answer just be like,
So the final answer, I'd be looking for 3 numbers.
yeah.
I'd probably have 3 boxes on the test, and it would say x equals, y equals, z equals.
Okay.
And you plug them all in. Yep, so 3 numbers. If you got all those answers, but you put them in the wrong boxes, you'd still get some points. But it is important to keep track of which one is which. All right. Any other questions on that?
No.
All right. So part of the reason that this was a lot of writing is because we were writing lots of letters. If you took all the letters out of everything we wrote there, that's probably half of all the writing. The only thing that is really important there are the numbers. We don't have to write these letters all the time. So instead of writing something like x minus y plus z equals 6, if you just write this, 1, negative 1, 1, and 6, this conveys exactly the same information as that. As long as I remember it's in alphabetical order, x, y, z. So tomorrow, we will look at using what's called a matrix to solve the system. So a matrix takes all the stuff we did today and it cuts out having to write all the letters. Some people don't like just writing the numbers, they like the letters because I don't know, just like writing them. But this is less writing. So it's just a more efficient way to organize everything that we do. And we'll look at that tomorrow. Okay, so that is the homework. Keep in mind it is just odds. It's not 1 through 19 all. If you do all, you're doing twice what you need to.
What unit is this? 10.1?
This is 10.1, page 541. Yep.
You should put the unit at the top because I always forget.
About to go